Sir, Ramakrishna, sir.
Yeah.
Sir, can you make your video on, sir, first for a little while, sir? Then you can share the PPT, sir, for our recording purpose, sir.
Yeah, 1 minute. Okay.
Yes, sir. Yes, sir.
Is it clear?
Yes, sir. It is clear, sir. Yes, sir. Now you can start, sir.
Okay. So, good afternoon, everyone. I am Ramakrishna Dutt. I am alumni of GEC of 2004 batch, and then I did BTech in Electronics and Communication Engineering, and then I went to MTech in JNTU Kakinada in Digital Electronics and Communication Systems. Then I worked in VR Siddhartha Engineering College and a few engineering colleges in Hyderabad as well as assistant professor, which I held different positions like project coordinator and ISO coordinator as well, and member of NBA committee as well, for achieving the NBA and other recognitions to the organizations. Then I moved to industry, especially solar industry, from the past 7 years. Right now, I am working with Enphase Solar Energy Bangalore, which is headquartered at the United States of America. That is my introduction. So with this, I will start my session.
Please proceed, sir.
Yeah. So today I am just giving you a brief introduction on IoT applications in the solar power industry. Basically, we will concentrate on the real-time applications where we are doing every day as a part of our delivery in the company. So this is the agenda, overview of solar industry, a brief overview I'll give, how many types of installations we have, then what are various components of solar industry, solar like mechanical, hardware, software, firmware, etc. Then I'll give a quick overview of Enphase, what we do, what are we into, what as of now we are in the current solar market. Then how does IoT relate to solar? What is the principle of operation? How we are integrating solar and IoT? Then what are various phases of launching the product? Then some value added topics which will be helpful for your career as well. Then a few question and answers we will have. So basically, why everyone are going to solar industry? What do we get from that? Basically, here are some glimpse of the solar industry benefits, which impacts the environment, which reduces your energy bill, your production, and as it's a free solar energy is a free green energy, so it's applicable everywhere as long as the radiation is there. And then less electricity loss during long distance transport, because if you lay cables, so you will have wire drops, wire resistance, and then transformer impedance will be injected into those cables, so all those will be we can reduce. And then we can have grid security as well, a type of standards which we follow in the industries, especially IEEE 1547, and there are some California standards, and those standards will vary from geo to geo, which will have grid security as well. So these are the advantages of what we are having in solar industry when a company is establishing as a solar based company in India. So we have robust demand, we have increasing investments, we have a government policy that supports who is establishing solar energy, including it could be a residential or it could be a commercial, whoever it is. If you are going to solar, so government will promote you, government will give you benefits back, We will get like 5 to 10% of revenue, whatever we are incurring every year in the company, we'll get as a subsidy because we are serving the country, and it is a green industry. Then like India, if you see, right, we ranked fourth among all the countries, so which is a great advantage for us in getting foreign domestic investments, etc. So those kind of things, we have the advantages of solar industry. So like I said, there is a robust demand, so technology always plays a major role here. So when there is an innovation, there will be a great demand. So innovation with demand, we can enter into the market easily compared to other industries like wind industry, like or any petroleum or other industries which generates power, including hydel. So this is one of the advantage we have in the solar industry. So that's why FDI inflow is coming. So like foreign domestic investments from Tesla, SolarEdge, other companies are coming into India and investing a lot of $1 billion. So which generates revenue to the to the country, as well as it gives a lot of employment. It gives a lot of impact to in the society, a lot of impact to environment, in all aspects. We are covering the solar industry. So there, like, these are the types of installations. Basically we have three types at a broader level. One is grid tie, another one is grid tie based backup, another one is pure backup, which is called as off grid solar. So what we does in off grid solar is we will not have the system connected to the raw power, which we call as grid in industry. The terminology of raw power, we will change as a grid. So in off-grid solar, we will just have the solar panel, then charge controller or some electrical components we will have. A battery bank will have, which we will store the charge when sun radiance is there. And then from battery, inverter will do its operation. And then we will power on the either generator or house, depends on the requirement. So this is a one type of disadvantage, where you have only solar and battery. You don't have a grid here. Now coming to the other in this is a grid tied solar, grid intertied solar without battery backup. So here you will have the system connected to the utility grid. The main disadvantage of this system is once there is no grid, so your entire system is down, because that is the one of the disadvantage of grid intertied solar. When I say system is down, means the solar system will be down, and as well as if you don't have backup, so obviously there will be no power to the house. But why people will go to this kind of things is because it is cheaper than the battery based solution. So this is the optimal setup, where you will have both grid as well as battery with solar. So this is the complete system. If you have, though if solar is not there, your battery can serve your house. And whenever your sun radiance is there, what it will does is it will push the excess power to the grid, and available power you can take to house. So in that way, what you can get is in this kind of configuration. So you are seeing a meter here, right? So what does this meter do? It calculates the net inflow and outflow to the house and from the house. So net inflow, let's say you have 1.2 kilowatt, for example. So, and if you have a solar plant at the rooftop of your home, which is generating 2 kilowatt, so your house will take to 1.2 kilowatt, and then so the excess 800 watts we will push to grid, based on the local guidelines which we will be taking while installation. And so what we will get is we will get revenue for that 800 watts. So the net consumption meter, it will nullify whatever the inflow and outflow. It will calculate the difference, and at the end of the month you will get the summary of that bill. So sometimes government will give you, sometimes you have to pay. So based on your consumption utilization. So that is the advantage of grid intertied systems, even with battery backup and without battery backup. So the only difference with battery backup is you can enjoy the power without no disturbance to the system, to the home, even in the absence of solar as well as grid. So what we do as a business initiative, we will do residential installations as well as commercial installations. So residential installations means smaller homes or apartments where we can install a few solar panels in the like roof of our homes. So from there we can get the power. Whereas commercial will be like higher range, they will be in the megawatt. Otherwise, we cannot earn the revenue of what we have incurred in that expense. So basically there are only two types of installations. There is the residential or commercial. So this is one of our recent installation in Bangalore. We installed in December 2019 in one of our apartment. So if you see, right, number of units from solar we produced is 41,148 kilowatt hour. So it's almost 41 megawatt we produced. So, and then number of units that particular site consumed is only 40,888. So it's like, if you see, right, this is of how much, 6 months, even in the COVID time. So this is the advantage if you install solar. So they got the revenue back. They didn't pay any even single rupee as their electricity bill, which used to be almost lakhs of rupees per month uh, before the installation. Then this is one of the recent US installation. It's in Monopolis. So this is in Monopolis, which is like a commercial installation we had, is a recent one in September we installed, which is operational now. So this is called commercial installations where we'll have so many panels. The one of the key advantage of these kind of panels, whatever you are seeing here, is they are bidirectional. So that is the new innovation in solar panel. So in solar industry also, there are like so many innovations coming in terms of panels, in terms of the inverters, in terms of the other balance of system materials. So like there are thin film solar panels, there are bi-directional solar panels, there are monolithic, monocrystalline, polycrystalline. Each company is developing their own panels based on the composition of what they can afford. Like we have so many variations of solar panels. So what are the basic components of solar PV system? The first main component is solar panel. You have so many types of solar panels. You can refer to the links. Then the conversion, how solar energy is converted to our electrical energy. So to that, we need to have the solar panel will do the irradiance to electrical DC conversion, and then a basic inverter. Usually an inverter will have two sections, DC-DC as well as DC-AC, where it involves so many our day-to-day whatever we are studying, the basic sensors, peripherals like timers. Then we will use control loops for implementing. We'll use phase locker loop. Sometimes what will happen is, like for optimization of the PCB of the inverter, what we do, we will have two separate microcontrollers if we want to design a high power micro inverters or high power solar inverters. Then we will have two separate controllers. Both DC-DC will have a separate controller and DC-AC will have a separate controller. They can talk each other using a serial peripheral interface or I2C or CAN, whichever the company decides or whichever the architect decides at that point of time, and at that and which gives a lower cost to the company and higher revenue. So all these matters a lot in deciding that component. Then we use filtering techniques to suppress the noise at different levels. We use encryption algorithms, both hardware level, software level. Because we at Enphase, we have our own ASIC. We will buy the IP cores of ARM, and then we will develop our own firmware into that course. So we need to have hardware encryption as well, and of course software encryption, because if it should not be the file, the hex file, whatever we are downloading, it should be encrypted as per the standard. Then comes the gateway interface. So once we have solar panel which generated the solar rays to DC, then our inverter converted DC to DC, again DC to AC. Now this AC side, whatever we have the data, everything, we have to talk to our gateway. So we have to send the data to our gateway. Otherwise, we cannot have the monitoring system. When there is no monitoring system, you don't know what is happening at the site. You cannot understand what, like if some errors or if some bugs if you want to clear. So you need to have some interface called a gateway interface. It can be a wired interface or it can be a wireless interface. Again, these are all depends on cost to the company. These are all depends on so many other factors as well. But basic, when you say interface, basic interface will come to our mind is RS-232, a serial interface. Then a recent technological changes are coming like Modbus, SCADA, PLC, then a differential bus like RS-485 or a CAN. Then these are wired interfaces. On the other hand, a wireless interface can also be have in the gateway, like a radio protocols like Wi-Fi or Zigbee, etc. Now you have a gateway interface. So gateway resides in your system again. So now how do you transport data to cloud? Because the ultimate IoT ends with a cloud. Without cloud, there is no IoT. So you need to have a transport layer protocols implementation with the TCP IP or UDP. And then you need to have application layer protocols, because from the gateway interface to talk to cloud, you need to have a mechanism of transporting that data, which often be used by the companies is MQTT, message queuing transport telemetry protocol, and the HTTP, because some of the applications reside on HTTP servers. So that we need to add that. Then we need to have again encryption here, because all the application layer protocols, right? And they are serviced by like if you see the layered model of networking architecture, OSI layered model, the layered model principle is a common principle that lower level will be serviced to upper layer. So that is the layered model concept. So application layer should be serviced by your session layer and transport layer, and then your session layer and transport layer should be serviced by your network layer. Then network layer should be serviced by your data link layer as well as your physical layer. So the each layer has to service the upper layer. So servicing to HTTP and MQTT will be done by the encryption, which is done in session layer. So that kind of implementation a cloud architecture should have. And then once you have a cloud interface, you cannot depend on web apps, because nowadays everyone are having smartphones, and people cannot wait to you if you open your laptop and show the things how they are opening on. So you need to develop mobile applications as well for different OS like Android and Apple iOS. So this is the like cloud interface uh, tasks whatever we have. These are some reference designs, Infineon and Microchip inverter, whatever they are having their own inverters. They can you can watch through those, like what are various components and all. So now let me just pause here for 1 minute. So let me show what we have in our Enphase as a system. So, like I told, grid tied is the one of the safest solution all over the world we have. But the main disadvantage is whenever there is a power lost in the grid, so solar inverters cannot be operated. So with that, what we are going to do in our next generation is we are coming up with the battery based mechanism. So that is what so that's how we have the current innovation. So with this, what we have done was, so this is like we have launched our product in the United States of America.
రామకృష్ణ సార్
Yeah.
యాక్చువల్ గా వీడియో ప్లే చేశారు కానీ షేర్ చేయలేదు సార్ అది.
Okay, I'll share you the links.
Okay, sir. Actually, you shared the presentation, sir.
Okay.
On your system, the YouTube has been run, but that has not been shared, sir. So that is a.
Okay. So I'll share the links anyhow, so we can go through. Yeah.
Okay.
So, like we have installed almost 930 sites as of now, since December 2019. All the ensemble sites, variation from 10 kilowatt hour to 20 kilowatt hour sites. When I say, they are customer homes, they are residential homes. So we are getting a good response there. And then the next product whatever we are going to launch is in the European market, which we usually called as rest of world. So which I'm working on right now. Basically, it's a small change in firmware as well as a small change in the um, software, which will just change the voltage to 40 60 to 30 50 with the same hardware. So soon we will enter that market as well. So nowadays, like every companies are looking like a common hardware you will have, but the software will only be different. So in that way, what is the advantage is that you can enter the markets easily without changing your hardware, because in any embedded system, in any embedded company, the toughest challenge for us is getting the hardware done at the targeted time. So if we don't have the hardware done at the targeted time, we cannot enter the market. So the competitors will catch your market. So always we need to chase. So that's why common hardware platforms are needed. So like thoughts from youth or thoughts from innovative ideas should come, like you should have a common platform, and only change should be in your firmware or software or whatever the APIs you are going to write. So in that way, what will happen is you can enter or you can design the systems very quickly. Within 3 to 4 months, you can roll out the products, different products. So this is Enphase system. I have explained already last time the same slides. I just wanted to again just to show what are our solutions we have. So this is our Enphase home energy solution, where the objective of this FDP is covered here. You have all the electronics, you have all the components of IoT, sensors, everything, like a cloud, hardware, everything, software. So this is a complete solution of IoT. I would say you have IQ inverter, you have the battery, you have the toolkit, which is a mobile app, you have the cloud interface, you have accessories. These are mechanical related. These are already installed Enphase inverters. And then this is Enphase Enlighten cloud interface. So this is our next generation 2.0, where we are going to change all the um, inverters in the rooftop. What we currently have IQ 7 and 6, and the new inverter we are calling as IQ 8. So the difference between IQ 7, 6 and 8 is 7, 6 are below 8 we are grid tied, and after 8, from 8 onwards, we will be off grid functional as well. So that is the advantage we are going to get. So what we do basically in the solar industry, so we have a solar panel which converts DC to AC into a common bus, and then the AC line is transported to the router, which is already also connected to the grid utility. So router gateway depends on the company to company, the terminology will change. So basically you can call this simple block as a monitoring system, where you will have a gateway. Again, a gateway is a combination of electronics. It's a combination of pure microcontroller or DSP based processor, based on the design of what we are going to have, which involves a lot of sensing, a lot of conversion, a lot of software embedded in that, a lot of OS based programming is embedded in that, which has to last so many years, right? So which needs to be having so many new features like remote firmware upgrade capability and encryption algorithms, and all those things are done in gateway. So at the inverter level, this is the basic power conversion we do. We will have a PV panel. Then we have a DC-DC controller. Then DC link, which suppresses the noise in the DC bus. Then we will have a DC AC conversion. Then AC filter as well, which suppresses again noise. Then it is connected to grid. So this is the basic overview of hardware. So if you see this, right, sir, can I know who are the audience? Is it only electronics and communication, or like other branches are also involved? Is it? Hello? Hello? Okay. So like I assume the audience are electronics and communication, electrical and CSCIT as well. So like if you see, right, this, if you look in a electrical perspective, you should look in a different way. If you look in electronics perspective, it will be in a different way. So what we have here, so from electrical perspective, so all these like DC DC, MPPT, capacitors, everything, they, we usually feel that they are all electrical based. So whereas if you see electronics only, right, if you see electronics only, you need to have only the firmware components, or you need to design the basic regulators and all. So but when comes to your industry or at higher level, you have to merge all the change, all the things, like it doesn't matter whether you are an electronics engineer or whether you are an electrical engineer, as long as you understand the product and the implementation of how you are going to do upon reading the documents and upon applying the knowledge of what you have learned in your curriculum, that matters a lot, rather than the branch of what you have studied. So what does DC-DC block will have? It basically, it will have a controller, like I said. It will have a few electrical things, and that should be controlled by the firmware in the controller. So which means you should be having knowledge on the peripherals of microcontroller. Basically, the first peripheral, whenever a microcontroller or a DSP processor, if you are studying, you should learn how the ADC is operating in that particular microcontroller, because each microcontroller will have different ADC components, different ADC mechanisms. One may have successive approximation ADC, one may have the other ADC, so, and one may have a dual input ADC. So because nowadays operational amplifiers are coming up with higher quad based systems, so in a single microcontroller you will have 8 to 10 ADCs as well. So in that way, what is the advantage we are going to get is, if you have 8 ADCs, so you can have 8 channels of sensing. So because the main advantage or the main requirement in IoT is, you need to have more channels in the system so as to sense different components. So you need to sense temperature, you need to sense voltage, you need to sense current, you need to sense pressure, you need to sense any other parameter, position of the device. So all those things, how it will be possible is, you need to have more channels in that system. So more channels means you need to have more ADCs. Why only ADC we require? Why not DAC at the initial stage? The reason being is, all our electronics, all our real-time systems are analog in nature. They are not in digital in nature. So you need to have analog as a ADC as a main component. You need to thoroughly understand how does it operates, how you can control ADC using code, how you can implement various effective algorithms in ADC. That matters a lot. Then comes your timers, peripherals, etc. in controlling the DC-DC block. If you say DC-DC block, right, you have an MPPT which calls as maximum power point tracking. What does this do? What does this algorithm does is, MPPT stands for maximum power point tracking algorithm, which means your DC-DC conversion algorithm should have an operating point Basically, if you see a transistor or FET, it will have an operating point. Based on the operating point only, you will have the regions of operation. If your operating point is less than one region, you will call it as a cutoff region. If it is in the middle, you will call as active region. If it is at the higher level, you will call as a saturation region. So the saturation region is called in the DC-DC section as a maximum power point tracking, which means you need to set the voltage and current of the solar panel to be operated at that point. Then only you can get highest efficiency of that particular panel. So then only you can get the optimized electricity from the available irradiance. So the heart of the DC-DC section is MPPT. Then comes the DC link. It is just a filter. So basically, in any conversion, you will have a ripples. You will have ripples. So you need to cancel that ripples, and which is called as an unwanted signal, right? So basically, you will have a capacitance there. Then a DC-AC inverter. Now you have a high voltage DC, HVDC you have. So we need again AC, because where we start, we have to end with there only. So the input, whatever we have, it should be an analog only to the grid. So DC AC, what it does is it will convert the available DC to AC using some control loops, and then you need to have a filter for suppressing the noise. So why we need AC filter also is, so grid will also have disturbances. So you will also generate a disturbance. Whatever you generate the sine wave from the DC AC inverter, it will not be a pure sine wave, though it is designed to, because there could be a sensing error in the ADC, there could be a conversion error, there could be so many errors. So that errors we have to nullify. That errors we will nullify using a famous concept called phase locker, so which is used to sync to the grid in the at the output side of the system. So now let us look into the software side. Now we have looked at the hardware side, right? So now let us look the system into hardware side. So these are the blocks of what we have. So basically a subsystem, system on chip, system design, PCB, system hardware. Those are all related to the hardware. So once we got the PCB, everything and all hardware, they will be mounting the transformers or any other equipment items, and then now comes to software. So once the board comes to hardware, from the hardware, so you need to write the drivers. So what are all drivers you will have? What do you mean by a driver? In industry, we call low level components, we call in software as a drivers. Low level components are what means you will have a timer, you will have an ADC, you will have a um, watchdog implementation. You need to have, you need to implement counters, you need to implement basic serial protocols to talk to the other gateway or other microcontrollers if the system has. So all that things we call as drivers, including SPI, I2C and all. Now we have drivers. So how those drivers can be performed? They cannot be performed on their own. So it needs to be driven. Those drivers needs to be driven. So whether they can be real time or whether they are interrupt based and all, it depends on the architecture of the design. So most of the recent systems are real time based. Whenever we have a real time system, you definitely should have an OS. So that OS should drive the drivers. So here you need to have object oriented concepts. So where which driver comes first, what is the sequence of driver, and what is the state machine you want to design, because the system means it's not only drivers, you will have system design as well. So system design we generally call in technical terms as a state machine. So whenever a state machine comes, you will have a sequence of states, starting from state 0. So state 0 can be something, state 1 can be something. You can have infinite number of states based on the that particular product. So all those states should be synchronized to each other by referring to the drivers, by referring to the overall functionality of the system. Then comes the middleware and apps. So what does middleware and apps does is, so OS level, we will end up with the basic gateway will end up with OS level, let's say. So now we have to interact with the other gateway. So middleware does that. What does middleware does is, we will have an export protocols where that is just an interaction, or you can say a carrier between your local gateway and the remote gateway. So that is what middleware does. And apps, of course, based on the different applications, different functionalities, based on either cloud or mobile or a local gateway. It could be any application. It could be any what do you call, user based application which is developed in the app layer. So this is like, if you see lower 5 systems, lower 5 layers till the system hardware is only our hardware. From upper drivers to apps, it's a purely a software based thing. So once you develop a system with the system hardware, once you freeze, if you change only drivers and real time kernel or whatever it is, then you can have n number of systems. So that's what the recent trends are going on in the industry. People are coming up with open source hardware, where you will have a fixed hardware. You can port your own software there. You can run your own application of whatever is your interest. So this is what open source and software and hardware. So you can see from 1991 to today how many open source platforms we have got in the industry. And similarly, open source hardware, you can see Arduino, Raspberry Pi, Forge, then and then so many are there, Legato, so many open source hardwares are there. So what is the advantage of these hardwares is, you can directly take their board just in Amazon or whatever it is, which costs you around 2 to 3,000 rupees. So you can run your own application. You can control entire system if you have a Raspberry Pi or Arduino or any other board. So that is the advantage of open source hardware. Similar implementation is all going to be done in the industry, uh, which will reduce our hardware cost and increase our productivity by releasing number of products in within less time. So how APIs are written? Once we have, this is the complete gateway and solar inverter, everything. So you have the electrical interface here, the green dotted lines. So whereas the inverter is the upper layer, so which has only software. So you will have a processor. It could be any DSP or any microcontroller, which has basic peripherals like ADC, DAC, timers, etc. And of course, pulse width modulation as well to change the frequency of the loops. Then driver controls you will have. Then transceiver, it could be anything. A transceiver could be an RS485 or a CAN or RS480, RS232, or any other protocol can be there. Then you will have this side, normally we call as a storage, and this side we'll call as a power management. So what it does basically, right, a 24 input channel AFE. So like I told, based on the ADCs, you will have number of channels. AFE stands for analog front end. So the more channel you will have better advantage in the system, so that you can sense that many number of analog signals. So that 24 channel, whatever you sensed, you will be converting, you will be using in different ways in the controller, so as to achieve our target to convert from DC-DC to DC-AC as well. So this is how APIs are written. Basically, all the control loops, everything we can write in any of the language, either C or C++, or sometimes we will use XML as well in the industry, based on the product design, how the architecture, the design is. So, so that is how we will write the APIs. All you should know here is every device, whatever you are seeing here, can be controlled, should be controlled, and we need to write the code for this, whatever the controlling everything we have. So code, when I say, you need to have driver development, then driver development needs to be controlled by the upper layer. Upper layer could be any OS based design, or any normal sequential design is also fine. So these once we have all the things, so before starting any product, we will have a phases of launching the product. So typically any product normally will take this much time, and these are various stages, which I projected here. So it could be different for different company as well, but mostly first five will remain same. Maybe the terminology may change, but the flow will remain almost similar. It could not be same, it could be similar. So what we do is we have to first gather the requirements. So requirements from whom and requirements for what. So when we are designing a product, we need to see who is our customer is. Like so that will be done by the marketing team. So once we find the customer, the targeted customers, so we will see what is the um, impact to that customer. So here I'll just pause for 1 minute. So why this requirements gathering will be done is like, so what we are going to achieve in any industry, how the industry grows, or how any company grows, is like you need to identify a social cause, a social problem. So then only you can enter into market easily. So otherwise what will happen is, anyone can develop product with whatever mind they have with and whatever knowledge they have. But so the marketing plays a major role to the company, because it's an ROI. So we need to spend a lot of amount in research and development. So spending amount is not the issue. What is the return on investment to the company, so that company can grow, as well as company can introduce new products, company can hire new employees, company can impact the industry as well with that product, company can innovatively make new products as well. So that's why we need to identify the social cause of the particular problem, and then that is where we need to find the targeted customers from the marketing team. They will do. Then what does all involve, like engineering, overall customers, manufacturing, certification, etc. How much time it will take, everything we have to map. Everything closely, this can be done for any project within 2 months, based on the size of project. It could be done in 1 month also, but it depends on the how many people are involved, how many people are how many markets we are targeting, which geos we are targeting, everything matters a lot. Like I said, always return on investment to company, target dates, resource planning, budget planning we need to have. So we need to forecast revenue, we need to forecast what the company is going to get upon investing x amount of money in this project. What is our revenue ROI in this project? So to execute the plan, what are our target dates? What is our resource? Whether we have enough resources in different teams or not. So if not, what is our plan A, plan B, everything. So we need to plan budget as well. This will take minimum to minimum of 2 weeks. Then the real engineering comes, prototype design, brainstorming, development, testing. So we need to design prototypes. We need to brainstorm the architecture, development, testing, etc. This is 2 months effort, which we will require mostly. Then we have to review the results of prototype. Where do we stand with whatever the requirements we got from the point one? So whether we are meeting that requirements or not, whether we are meeting the costing requirements, everything or not, whether we are meeting the timeline, all those things. So we will see and we'll review. Then actual implementation will come. So, and again, testing as well. So once everything is done, we have to go through a certification process. So like in college, like the way you have exams, every product has to undergo a certification process, because safety related, there will be so many certification process we have to go. Then only we can sell a product in the market. Then we will have minimum release called alpha, a set of a few less than 10 sites in any industry. Then beta, mostly it will be 10 to 100. Then limited availability, it could be 100 to 1000. Once we see all the issues which we observed in alpha, beta, and the limited availability, then only we will go to the final customer release. So we keep on fixing the issues what we observed in the real-time scenario for alpha, beta, and the limited availability. Then once we are confident enough in clearing all these phases, we do have our limits in clearing. For alpha, what is the uh, benchmark we should have? Beta, what is the benchmark we should have? Limited availability, what is the benchmark we should have? We will keep that. Then we will analyze ourselves, we will refine ourselves, and then we'll finally go to the final customer. So if you see, right, lot of almost 2 plus 2, it could be almost a 1 year of effort for introducing a new product into the market. So now industries will think that where we can reduce. So because 1 year for one project, and with whatever the revenue is, so there will be another company, company B, which they may give at 6 months itself. So but we need to have our quality standards, we need to follow so many rules, everyone has to follow that. So there could be these trade-off between these things. So it may not be exactly whatever I projected here. It could be somehow less or more as well, based on the experience what we got in each step. And especially if you see now, COVID has impacted all over the world, almost from past 8 months. So during that time we should have. So that's why fast execution is also important to any company, and we should have our own mitigation plans. If plan A is failing, we should always have plan B of how to execute the things in parallel, how to execute the things in faster time. So those kind of learnings we should have. So this is a engineering and management related things. So now I will just give some of the added values, whatever we have. In addition to that, coming to the industry, we should have all these additional things when we are doing real-time applications. So when we are doing real-time applications, we should have in-depth knowledge on DSP processors, as well as uh, microcontroller based processors. So in-depth knowledge means what? So we need to have what do you call, thumb instruction sets. We need to have, so if you take DSP processors, right, so they are having extensive features in the sense they have a parallel processor which we call as a co-processor. In TI they called as control accelerator. So where you can run you can offload the main programming to the sub programmer. So that kind of knowledge we should gain, because that is what going forward all the risk machines we are going to have. So because whatever we have, the quad and the dual core processors, the advantage of those we have to make use of that. Then only our code will be efficient, and we can save a lot of memory in the processor. So That's why in-depth knowledge we need in these kind of DSB based processors and um, watchdog implementations, etc. Then, so then various peripheral control of microcontrollers. Like I already have told, ADCs, timers, then DAC, PWM, whatever it is. A peripheral can be anything like SPI, I2C, CAN. It is immaterial. But in-depth knowledge, we need to be aware. The reason is, so especially in real time, the efficient way of implementation is very much needed, especially like DMA based implementation. So normal memory access and direct memory access, they both are different. So if you concentrate on DMA based approach in peripherals like ADC and buffering, that will be an added advantage. Then OOPS concepts, object oriented programmings, then OS based embedded system design. So recently whatever we are having, so we are all getting the OS based embedded system design rather than sequential based design. So we need to imbibe the knowledge on the operating system concepts, especially the multitasking, scheduling algorithms, those kind of approach. Then memory management techniques. So this plays a vital role in the industry or in the real time applications, because how efficiently you are managing your memory, how efficiently you are managing your flash, that matters a lot. Because soon if you occupy the more memory, then what will happen is you need to change the controller at some point of time. So people who are very much intelligent in memory management techniques, that will be added advantage for them. Then we have to involve machine learning and AI methods as well, because almost microcontrollers now they are coming with the neural networks implementation as well. So because Python has evolved a lot in past 4 years, so where everything you can control from home, so which can be done using AI methods, machine learning, some sort of artificial intelligence and neural network techniques. Then we cannot depend on only one programming language. Like we cannot depend on only C or any other language. We have to learn like so many languages like Python, C++, XML, and of course cross compilers. Because if you see, the advantage of cross compilers and this CMake and make is, so you have a 2 3 languages in the common code base, because you have OS, you have drivers. Basically drivers are written in C or C++, and OS will be written in C++ or Java, for example. So at the end of the day, it could be a common file. So common file, how you will compile or how you will make them is using cross compilers, and you need to have a CMake kind of approach where you will have different languages which you can build the code easily. Then various IDEs and its updates. So day by day, IDEs are coming up with different plugins. Like you can have IDE with the Python plugin, you can have IDE with the Java plugin, you can have IDE with the other XML plugin. Because everywhere as the innovation is going on, IDE is also coming up with different workspaces. Workspace will have different approaches, so all those knowledge you can learn, you can improve. Then flash memory, so like this I have already covered, but the main thing what we may get added value is, so any system, any embedded system will have a bootloader. So it plays a major role in the system, whether to boot up or whatever it is, to not boot up. So implementation of bootloader is done in Flash, which plays a major role. So you need to have so many like innovative ideas in implementing the bootloader for efficient usage of memory, because bootloader will decides from where the main controller should boot up. So that's why flash memory design is very much important. Then version control systems. So once you develop the code recently, now coming days and all, what the industry will do is, so whatever you are writing code in whichever language it is, so it will be stored in a common server, because you cannot store the code in your local machine. The reason is, if your local machine got some problem, so then everything will stop to the company. So that's why companies will implement version control systems, which are paid services as well as which are free services as well. Some of them are open source as well. So basically, Git, ClearCase, SVN, they are like they are called as version control systems. So why we use version control systems is, let's say 10 members are there in the project. So each of them will write X number of lines every day, or whatever the sequence they have. So everyone has to store their code in a common repository. The otherwise, what will happen is, if something goes bad to the local machine, that whatever the data, whatever we created, will be lost, and it will delay the projects. And it's not safe to keep everything in the personal pieces. So we need to have a version control system. So that's why we will implement this as well. Then process based approach. So like every day, we need to have the regular meetings, weekly, bi-weekly, quarterly, to assess ourselves, where do we stand to reach our targets. Then lot of things, so you should be a multifaceted person. You should learn different things. If you are learning only coding, that will not give you anything. So like different things comes at different stages in your growth. So especially the documentation, like flowchart preparation, UML diagrams, etc., etc. In how to write the flowchart, how to write the diagrams, and then how to write the content of that particular project. So whatever the driver you are developing, so let's say you write the driver, let's say other person comes, for example, after 1 day, 1 year, so he has to work on the next project. So he should have a reference document or what you implemented in the previous project. So that documentation, that skills, we need to improve ourselves. This is a typical product life cycle process, from the concept, design, prototyping, and then validation, certification, and then finally, once certification is done, we will approve the manufacturing services. So concept phase, like I told, we will see what are the customers, what is the concept we are going to implement, everything. Design phase is like what sort of components we need, what sort of software we need, what sort of controllers we need, all those things. Then prototyping with small experiments, then validation, finally certification, and then manufacturing. So this I have already covered version control system. So just it's a diagrammatic representation. So you will have a central repository. So you will have X number of persons here. So everyone will push the code, though it could be a single line or X number of lines. That doesn't matter. But whatever you write, whenever you keep in the central repository, that would be a safe thing for company as well as for you to see what are all the errors or what are all the back. If you go to 10 days, 20 days back also, you can see clear things, and you can directly pull that particular file and you can start using that particular file. Suppose, for example, we crossed almost 1 month, say for example, and whatever the design now we have implemented, it could be a non required design, for example. Then we can, if we want to go back to the previous design, then we can just pull within 2-3 minutes the previous code and compile the new code. So that is the advantage of version control systems. Not only safe, it will reduce our time, and it will reduce who introduced the bug in the system. It will reduce so many other aspects as well. It will increase the delivery of the product. So once our like software side, once we develop the code, everything is done. So before deploying, what we have to do is we have to test it, and testing should be done in multiple times for each deployment, for each check-in of the code from each person. So that concept, what we call in the industry, is CI/CD, continuous integration and continuous development. So this is like a continuous integration, which means day one, for example, if I have done X portion of the project, day two, X plus delta if I do. So that X plus delta should not have an impact the other way, should have the functional impact, but should not have the breaking impact of the system. So like that, every day, whatever if there is a new check-in comes in the code, so automatically the system will run the test, so as to ensure, okay, the new commit is safe, new code whatever is built is safe to run, so as to deploy to the customers. So that is how the everyday check-in continuous integration is done. So once you commit the code, so automatically system will build the code, so there will be no manual intervention here. So we will have a set of unit tests run automatically, which will be triggered without a user interaction. Then deployment will be done in the local system. Then testing phase will go. Then product deployment. So at each stage, you will have unit test has its own approval. Then this test will have its own approval, and final deployment will be this. So what does continuous integration does is, it will, once the code is committed, we will have unit and integration tests. Unit tests are a modular level test, whereas integration tests defines to a system level test. Then deploying to test environment. So we will have a assumed test environment, that which will have a test scenarios, possible test scenarios which we could get in the field. So that some of the scenarios we will have automatically pre-programmed. Then we'll have the check of acceptance criteria, and then deploy to production environment. So this is what continuous integration and continuous development, which recently every company is going through. Otherwise we cannot have the continuous feedback from the automatic system, whatever we will have. So with that, I am pausing my presentation. We can quickly take some few questions if anyone have. Hello.
Sir, can we go for the questionnaire, sir?
Sure, sir.
Participants, so you are requested to share your doubts either in the chat box, or you can raise hand and you will be unmuted. Ramakrishna sir, there is a question, sir.
Yeah, let me see.
I hope you are. Can I read out, sir?
Yeah, time to market, is that the question?
Yes, sir. And before that, one more is there, sir. How can IoT play a vital role in solar power systems?
Yeah, so that's what. So IoT basically it stands for Internet of Things, right? So any IoT basic components, if you see, it should have a sensor, it should have some control algorithms or some control hardware, which we technically called as a gateway, and then the final component is the cloud. So these three are primary components of any IoT based system. So when you say solar power, right, we are sensing solar radiation, everything which is in analog nature, which will be sensed by the control product called gateway through ADC, analog to digital conversion. So then the ADC data, which is processed by microcontroller, will be transported to gateway, and then in local gateway, and then local gateway will transport the same data to the upper gateway called as cloud interface through MQTT or whatever the protocol which is defined in that particular system. Now coming to time to market, the product is very important. Can you share hurdles you come across for a particular product? Yeah, so like hurdles means it depends on various factors. It depends on hardware, it depends on software. Sometimes the hardware is ready, firmware may get delayed, or sometimes the hardware may be get delayed because of a lot of factory related issues. Or sometimes, for example, if even if you have money and all, if the vendor of particular microcontroller company, they don't have particular components. Let us say I need, for example, 1,000 units I need to manufacture. So if the vendor don't have 1,000 microcontrollers, so that all will delay, right, everything. So those kind of delays can be there at any stage. So but what we have to do is we should not be panic in doing those. So that's why always, like I told, uh, we should have a mitigation plan. So industries are more experienced, so like marketing guys, and especially all industries, they will deal with product line managers, so where they are efficient MBA graduates, so where they will think, like if you see techniques they will follow, like 8-dimensional analysis, where we can fail in different angles. So if we fail in that particular angle, what could be our mitigation plan? Immediately we should come up with, we will already have mitigation plan. So that's why normally, right, in manufacturing we will not manufacture everything at a single site. So these kind of smaller things, if we can imbibe into the system, we can reduce the hurdles. Of course we will have, but we can reduce the impact of that particular thing in releasing the product. Before venturing the marketing solar manufacturing solar sector, does we have to complete some certificate course? That depends on yeah, if we are venturing to manufacturing solar sector, yes. So what I advise you is, um, there are certification courses conducted by government of India. I am also one of the certified member in that. There is a iAcharya website in government of India. It costs us just 500 to 1,000 rupees at various levels of installations. What I advise is, whoever are interested in solar, they can go through that courses, which are less cost 500,000, and just it's an online exam. You no need to go, like if you take NPTEL, we need to write online. We don't have online exam, I think, as of now. They do have some solar certification courses, but the disadvantage in NPTEL is we have to physically present there for writing exams, which I am also facing, which I couldn't also write so many, though I am interested. So whereas these kind of things we can write online itself, we can get certificate online itself, which will save a lot of money in traveling, lot of money in so many things for us. Um, which product you will suggest for IoT based hardware product life cycle? So product life cycle depends on industry to industry, company to company, everything matters. So what I suggest is, like there are, if you go to internet, right, there are so many protocols like approach, like waterfall model, V model, agile model, depends on um, your interest. It could matter, it could vary based on person to person. So that's how I can suggest. It can be anything which you can refer to internet. But the agile process and waterfall model, V model, these are the basic models which companies will follow. And like recently Microsoft Outlook, they are also coming up with different product planning plugins into the Outlook itself. So that could also be one of the option. So that's all. I think I have answered all the questions. Yeah, so one more question I think someone asked. Indian supply frequency is 50 hertz and US maybe 60 hertz. How it is managed, sir? Yeah, so how we will do the project what I am doing is US based project, right? Where we don't have 60 hertz here. So usually industries we will have a equipment called programmable power source, where the input is our local input. It could be three phase or single phase based on the rating. But whereas that programmable power source, you can program to that to 240 60 hertz. It could be a line one line two based approach. It could be a split phase, single phase, three phase, depends on that particular hardware. So we have devices which are available in market. So many companies are giving those AC sources, which we call as programmable power sources, both DC and AC as well, including load also. We can have a programmable load. So I think that's all questions, sir. I don't see any new one.
Yes, sir. So participants, any clarifications? So you can just put that in the chat box.
Okay.
Okay, sir.
Yeah.
So thank you so much, sir, for
Thanks, sir.
your valuable time with all of us and
Thank
giving
you.
your inputs.
Sure.
Thank you so much, sir.
Thank you.
Thank you, Datta Garu. Thank you
Thanks,
so
sir.
much.
Yeah.
Thank you.
Okay, sir. Bye.
And dear participants, so in our personal participant portal, so feedback is activated. So it is under the in the left side under the feedback tab. So we are getting that particular feedback. So you are asked to give that particular feedback. Some questions are there, and the rating is there from 1 to 5, where 5 is excellent and 1 is the worst. So you are requested to please give the feedback. And at the last, you are asked to give 2 names of the resource persons. So where you felt good. So you need to mention the names of the particular resource persons. So names of the resource persons of this FDP I posted in the group. So for your reference, so you can just find out that, and you can fill that particular feedback form in the ATAL portal. So that is compulsory for getting that particular feedback, certificate. So I request you to fill that feedback which is in the ATAL, which is been activated. Go through it and just fill that one. And once again, we'll be back at 2 o'clock for the third session. And as you know that, so 3:30 there will be a valedictory function, and after 3:30, so we'll be having the quiz, which is for 20 marks. Sorry, 20 bits, 40 marks, and 30 minutes of the duration. So that quiz is compulsory, and you should get 60% in that particular quiz. And also you will be given a feedback form during that valedictory function. So we request you to fill that particular feedback form also. So thank you. So please be back at 2 p.m. for the third session. Thank you, sir.